Hey guys, and welcome back to another week of science class. We're going to continue on talking about chemistry. Please let me know if you're having trouble with anything. I'm more than happy to help you. And let's just jump right in. So today we're going to focus on a new kind of modeling for atoms and their electrons, because I'm noticing that a lot of people are struggling with the valence electron thing. So I want to slow down just a little bit before I move on to covalent bonding. So we call these Lewis dot structures, or sometimes they're just called dot structures, dot formations, however you want to call them. I've always just called them Lewis dot. They're named after a guy. His name was Gilbert Lewis, and he's the guy that basically we have to thank for our definition of covalent bonding. He didn't discover it until like 1918, so fairly recent when you take the whole realm of science. Let me get a picture of him real quick. Voila, there is Gilbert Lewis over here. Bam, there he is. So let's talk about valence electrons really quickly, or maybe not so quickly. We'll see. So valence electrons are the electrons that are going to be doing all of the work when we're forming molecules, when we're forming compounds. They're the ones that are interacting with basically the outside world, because they're going to be the ones that are in the outer shell in terms of energy. So let's look at a periodic table, and let's just go through and just make sure that we understand how many valence electrons we can find in all of these different kinds of Okay, so Lewis dot diagrams are going to be a little bit different than the Bohr diagrams because instead of showing energy levels, we're skipping that entirely. We're assuming that we know that we have other electrons that are not going to be shown. Instead, we are only going to show our valence electrons, meaning those ones on the outside shell. So those are the ones that are interacting with other molecules, or really other atoms to form molecules, I should say, if I really want to be accurate, and the ones that are moving around. So we are going to draw a couple of these, and what I would do if I were you, I would make sure you take notes during this video, pause it, all that good stuff. And B, once you start to get the hang of it, I would pause it right before I give the answer and then see if you can guess it correctly. So let's do a Lewis dot diagram just to see. We're just doing atoms right now, and eventually we're going to be able to do this for more complex things like molecules. So let's go ahead and take oxygen. I like oxygen. All right, oxygen is right there. I circled it on our periodic table. It's number 8, right? So oxygen has an atomic number of 8, but look at how many valence electrons are available to us. We are going to have 1, 2, 3, 4, 5, 6. So the way that you draw a Lewis dot diagram is you draw the symbol in the middle. So I'm just going to draw an O, okay? O for oxygen. Then you represent all of those outer shell electrons. You represent those with dots. And those dots, you almost want to kind of imagine there being a box around your symbol here, because they need to all fall under, they all need to go on 4 sides. You don't just put them wherever. And you can only put 2 on each side. So I'm going to draw 1, 2, 3, 4, 5, and 6. So in other words, it would look without the box. You don't draw the box when you normally do this. I'm just doing that for representation. It would look something like this. Now you could draw it like that. You could draw it like this. However you want to, as long as those dots again are on the right sides of the oxygen, and that you're not putting more than 2 on each what would be like the side of the box, if you know what I mean. So that is an example of a Lewis diagram. Let's do a couple more. I'm going to erase my stuff right here so that you guys can see another one. Erasing all of my drawing. There we go. So let's go ahead and let's do chlorine. Chlorine is number 17. Now, am I drawing 17 little dots? No, because not all 17 electrons are going to be valence electrons. Only some of those are. So how many valence electrons are going to be in chlorine? We have 1, 2, 3, 4, 5, 6, 7. So 7 electrons here, okay? So I'm going to draw chlorine. Draw my symbol. 1, 2, 3, 4, 5, 6, 7. Cool. All right, let's do one more. So I'm going to do another one, and again, while I'm erasing, or whatever, if you want to pause it while I'm doing it just to see if you guys can get this on your own, that would be awesome. Then we're going to actually do a Lewis dot diagram for an ion, because we just did those. Whoop. So let's go ahead and pick one. Let's pick carbon. Carbon is a good element. We like carbon because we're based out of carbon. Yay. So carbon has an atomic number of 6. However, do we have 6 valence electrons? No, we only got 4. So we are going to do 1, 2, 3, 4. Bam. That is our Lewis dot diagram for carbon. So let's do another one, but this time I'm going to do ions. Now remember, what's special about ions? You should know this from last week. If you guys watched the videos, if you guys did the activities and all that kind of stuff, then you should have a firm idea about what an ion is. So remember, just to recap, an ion is a particle, let's say, yeah, let's go with particle. A particle that has gained or lost electrons, okay? Which means it is charged. Bam. So it's going to usually be an atom that is going to be doing the gaining or losing of electrons, although sometimes when atoms get together of certain types, you can have something called a polyatomic ion, which I talked about in my brief kind of answering your questions video. But don't worry about that one. So let's just go with an ion, a regular old ion, and let's go with sodium. Sodium is over here, it has an atomic number of 11. So I'm going to draw my symbol. That's always how we start with our Lewis dot diagrams. Drawing my symbol there, and then normally what I would do, there's only one valence electron here. But what's going to happen to that one valence electron? So when we form ions, remember, we're gaining or losing. We know that this is on the left side of the periodic table, so we're going to lose that electron. And now it's just going to look like the symbol with a little plus sign because it's lost an electron, right? Okay, so then how would we draw salt? Remember, salt, table salt that you guys eat on your food, all that kind of stuff, is going to be sodium plus and chlorine minus. So if we were to draw that, we would actually put two of those Lewis dot diagrams together. So chlorine is going to be, it normally has 7. So 1, 2, 3, 4, 5, 6, 7. However, to make sure that it has a negative charge, we gotta add one more electron. Remember, we're adding more negatives. That's why it's turning negative. So I add another electron right there, and now we have sodium chloride. We got our table salt. That's how you would show that in terms of a Lewis dot diagram, Lewis dot structure. We're gonna use these a little bit more later this week, so we'll continue practicing with them. I'll give you some more practice to work on these. I would just try your best on seeing if you can go through the periodic table and do this. Make sure when you're doing that, if you decide to practice on your own, take out these transition ones, okay? Transition metals, the ones in the blue there, they're kind of weird because they can actually have many more, or maybe not that many, but they can have more than 8 electrons. They don't necessarily always follow the octet rule. So when you add those into the equation, it gets a little bit more complicated. So stay away from those. Anyways, that's how this video is going to end, I guess. So good to hear from you guys over email and all that kind of stuff. Look out for your Zoom session. It'll be different for each class. So look out for that, and I hope to hear from you guys soon. All right, have a good one.